Today I'm going to be disassembling this motorized micrometer. This is in, if the autofocus would go, there we go, HSI Illumina motorized micrometer. It's kind of an interesting design. Yeah, I'll go ahead and start with the disassembly. Yeah, this uses a NEMA 8 stepper motor and has a travel length of 12.5 millimeters, I believe. That's correct. So this on the top here is a optical limit switch, which is nice on a micrometer. There's just no contact. Things keep quite clean. Let's see if I zoom in here. As you can see, this is just a beam breaker optical switch. So this is power, ground, and then I'm not sure why there's 2 sense wires, to be honest. Might be something a bit more complicated. I don't have the driver with this motor. And then if you look here, this little metal tab here is the part as the motor moves back and forth. So I'll just kind of spin the motor by hand here. You can see this metal tab moving back and forth very slowly. It's moving back right now. And that's hooked up to the optical beam breaker here. So next thing I'll do is unscrew this, which is supposed to be a mounting for mounting the motor onto a shaft like this. And here we can see the spline shaft sticking through a spline bearing. Zero backlash spline bearing. Very nice design. So I'll go ahead and move these 4 holes, these 4 bolts. There we go. I quite like this NEMA 8 design. It's very compact. Although 12.5 millimeters isn't very much travel for something like this. Still, it's, I think, pretty impressive. There we go. And then this comes off. Okay, let me turn this autofocus off. This is quite bad. There we go. Maybe zoom in a bit. There goes the focus. There we go. Okay. So this is a spline shaft bearing here. You can see, and then on this shaft here. See, I do want the autofocus. And on this shaft here, this is a spline shaft. If it would focus. Okay, there we go. You can see the splines on the shaft. This fits into this bearing here, and I can go ahead and press that bearing out. And Jesus, this autofocus is horrible. There we go. So you can see this bearing here slides onto the shaft, and I guess it's not quite zero backlash. There's maybe, wow, almost a degree of backlash there if you see. Yeah, that's actually quite loose. That'll introduce quite a bit of backlash in this motor. Well, anyway. So on the back of this motor, there's an encoder. Not quite sure what type of encoder this is. I don't see any optical. I do see an optical element there. But this is just an aluminum disc, so it's quite hard to track on. Anyway, so to get this out, I'm just going to unscrew the shaft from the motor. There's a threaded bushing in the center of the motor shaft here. Seems like they had a custom motor made to get this done. Can't be cheap. See what I mean? It's quite a long shaft for only 12mm travel. I guess they want to keep it from jackknifing and binding up in this low torque NEMA 8 motor. So here's the screw. Quite an important piece. And this is a two-part assembly. So if I take it and unscrew it here, it should break. There it goes. So the actual micrometer screw is a two-part threaded. So this is the actual micrometer thread. I'm not sure what pitch that is. Probably something around 200 micron per turn, if I had to guess. And then there's another smaller screw here, which looks like maybe an M3 or so. And that screws into the back of this spline shaft. And so this can be a separate component. Presume that's why they've done it that way. And then this flag piece has a notch here that indicates against the spline shaft. So you see there's a little notch there. So that snaps into this and keeps it from turning. And those are the expensive parts. Onto the motor. This was probably the most custom part of the whole design. So this part here, this encoder wheel, with some persuasion, comes right off the back. There we go. You can see this is just looks like it maybe was crimped on. You can see there's kind of some teeth there. Perhaps they use a crimping tool to get this on. Oh, actually, you can see, I don't know if you can see it, but I can see it. There's a optical pattern on the disc here. So it looks like it is a simple optical encoder, just like, you know, counting beam breaks, essentially. There's the optical element. I'll go ahead and take the motor apart now. Let's see, I'll probably need both of these. It's too big. And you can see right on the back of the motor, they've just simply tapped some holes for this encoder. See, right in the back of the motor. housing there. I've just simply tapped holes for this encoder to mount. And this is the most custom part about the whole thing, is this custom shaft. I had this motor apart. I think the shaft might actually be in backwards. It doesn't horribly matter. It would affect performance a little bit, but not significantly. So you should really loosen these in a star pattern. I didn't do that, but and this should just pop apart. Little spring washer for bearing preloading. It needs to go in here. Oh, looks like there's two. And you'll notice there's two on the front one, but none on the back, and that's because normally when you use a micrometer, they're spring-loaded in this direction. And so by putting both preload washers in the front, you're taking out any springiness that would be in the back bearing assembly, so that the micrometer doesn't flex under load. Yep, this is just a normal NEMA 8-stepper motor, bipolar hybrid stepper, 2 coils. And that's where the magic happens. So this is a threaded bushing in here. Quite a custom piece of hardware. I'll just go ahead and lay all this out now. Alright, there are all the components. Hope you found this useful. Thanks for watching. As I'm editing this, I wanted to add a couple more things. First is, this is the encoder board. You can see up here, this is the transmitter and receiver. It's kind of cool. You can see the wire bonding down to the actual package from the semiconductor device. And this is on a basic board. Here's the back of that board right here, if that's useful. And then I took some pictures of the spline shafts. So here's the back of the spline shaft. You can see the splines running here, running along the sides more clearly, and here's the back threaded hole. Here's the front of the shaft. This is the micrometer pusher, and again you see the splines. This spline shaft is made by THK. And I wanted to comment about the rotary backlash. I noticed that in the ball bearing, so you can see the spline shaft profile here, these 4 notches, and the grooves run through here. I noticed that the ball races, which should be entirely filled with balls, is not filled with balls. So I believe some balls must have fallen out. I got this micrometer from someone else used, and they must have lost the balls from this. And I'm assuming that's why there's so much backlash in the system. So, hope you found this video useful. Give it a like if you did. Please leave a comment if you would like to see something else. And thank you.